Hi everyone. Today we are going to do exercise 1.6 of the chapter Number Systems in the Class 9 Mathematics NCERT. So before we get to this exercise, I've written 4 formulas on the right hand side of my sheet. These are formulas that we are going to be using extensively throughout this exercise, and hence it's good to keep them on the side to refer to them. So let's just get to the questions. The first part of the first question is asking us to solve for 64 to the power 1 by 2. Now 64 can be written as 8 square, and thus this becomes 8 square to the power 1 by 2. Now if we see, this is in the form of formula number 2 on my sheet over here. AP to the power q can be written as a to the power p into q. Hence, this can be written as 8 to the power 2 into 1 by 2, which is simply 8. Moving on to the second part. The second part is asking us to solve for 32 to the power 1 by 5. Now we know 32 is the fifth power of 2. It can be written as 2 to the power 5. Hence this equation becomes 2 to the power 5, 2 to the power 1 by 5. Now using the same formula, formula number 2 again, over here we will get 2 to the power 5 into 1 by 5. And the powers cancel themselves out, and we're left with just 2. Third part of the first question is 125 to the power 1 by 3. 125 is the cube root of 5. Hence, we can write this as 5 cubed to the power 1 by 3. And again, using formula number 2, we get 5 to the power 3 into 1 by 3. The powers cancel themselves out, and we are left with just 5. We'll move to question number 2. The first part of question number 2 is asking us to solve for 9 to the power 3 by 2. Now we can write 9 as 3 square, and hence this becomes 3 square to the power 3 by 2. Again, using formula number 2, just like we did in the first question, we can arrive at 3 to the power 2 into 3 by 2. Here, the 2 will cancel itself out in the numerator and denominator of the powers, and we're left with 3 cube, which is 27. The second part of question number 2 is solve for 32 to the power 2 by 5. Now again, we'll represent 32 as 2 to the power 5 whole to the power 2 by 5. And using formula number 2, we get 2 to the power 5 into 2 by 5. Here, 5 cancels itself out in the numerator and denominator, and we're left with 2 square, which comes out to be 4. And that's the solution. The third part of the question is also similar. Here we have 16 to the power 3 by 4. Now 16, as we know, is 4 square. So we can write it as 4 square to the power 3 by 4, which makes us able to reduce this as 4 to the power 2 into 3 by 4. Here I've used the second formula again. and we reduce this to 4 to the power 3 by 2. Now, further, we can reduce 4 as 2 square, and hence our solution becomes 2 square to the power 3 by 2, and on further reduction we get 2 to the power 2 into 3 by 2. Here 2 cancels itself out in the numerator and denominator, and we get 2 cube, which is equal to 8. Now, a shorter way to do this could have also been that rather than representing 16 as 4 square over here, we could have directly written it as 2 to the power 4 to the power 3 by 4. And here, on using the formula, we would have got 2 to the power 4 into 3 by 4. 4 would have reduced itself, and we would have got 2 cube, which is 8. We could have avoided 3 more steps by directly representing 16 as 2 to the power 4. We move on to question 3 of this exercise. The third question is asking us to simplify the following. The first part being 2 to the power 2 by 3 multiplied by 2 to the power 1 by 5. Now, over here we can definitely use the first formula, which is a to the power p multiplied by a to the power q, which is a to the power p plus q, and hence substituting this formula to our given question, we get 2 to the power 2 by 3 plus 1 by 5, which then becomes 2 to the power 10 plus 3 upon 15, further simplified to 2 to the power 13 by 15, which is our final solution. The second part is 1 by 3 cube whole to the power 7. Now, we can reduce this in the following manner. 1 by 3 cube can also be written as 1 by 3 whole cube. Over here, we know that 1 cube is equal to 1, and hence we are able to do this. Whole to the power 7. Again, using the second formula out here, we get 1 by 3 whole to the power 3 into 7, which becomes 1 by 3 to the power 21. I could also simplify it further and write this as 1 by 3 to the power 21 just in the denominator. Both of these would be a correct representation. However, the best way to represent this would be 3 to the power minus 21. The third part of question number 3 is 11 to the power 1 by 2 divided by 11 to the power 1 by 4. Now here we're going to be using formula number 3, which is a to the power p divided by a to the power q is equal to a to the power p minus q. And reducing this given question with the help of this formula, we get 11 to the power 1 by 2 minus 1 by 4, which is 11 to the power 1 by 4. And that's the final solution. The last part of this exercise is 7 to the power 1 by 2 multiplied by 8 to the power 1 by 2. Now here we are going to use formula number 4, which says a to the power p multiplied by b to the power p is equal to a into b to the power p. So reducing this with the help of this formula, we get 7 into 8 to the power 1 by 2, which becomes 56 to the power 1 by 2. And that's the final solution. Now this brings us to the end of this exercise. Thank you for watching. In case of any questions or any concerns, any comments, leave a comment below, or you can reach out to me on the email ID mentioned in the description. Thank you once again, and see you for the next exercises.